This is 1998 AP exam question, AP Physics B, and it states, in the circuit shown above, A, B, C, and D are identical light bulbs. Assume that the battery maintains a constant potential difference between its terminals. The internal resistance of the battery is assumed to be negligible, and the resistance of each bulb remains constant. Draw the diagram of the circuit in the box below using the following symbols to represent the symbols in your diagram. Label the resistors A, B, C, and D. Refer to the corresponding light bulbs. So we're gonna scroll right here and maybe redraw the picture first before I start drawing, because I have to scroll the screen and I won't be able to show you the screen at the same time. So pause, redraw the picture, and then when you have that picture in front of you, I'm going to be explaining what you see in your picture and in what I'm drawing. I will probably scroll up and down, but it's nice if you have a picture in front of you. So it looks like we have a battery, and then I have a resistor A, and then, or maybe I will do it right here so it's going to be easier. So I have a battery, the positive is on the top, the negative is on the bottom, so the positive and the negative is on the bottom. Then I have resistor A, and then I have resistor B, and then I have C and D. Looks like B and C connected together, so it looks like you're gonna have B, C, and then D, right? I have first resistor, and I have another resistor. So I have two of them in this line, and then I have one more in the other line. So A, B, C, and D. And I'm going to redraw it below where it's easy for us to refer to the picture, cleaner picture. So this is what I have, and often in physics books, you can use either abbreviation. In physics books, this is abbreviation for engineering books. And in physics books, instead of this, you will see this. So that would be a resistor. So it's not sure if on AP exam they would mark you wrong if you did the other one, like the ones that I did. But yes, they like these guys. So I redrew them. Now list the bulbs in order of their brightness from the brightest to the least bright. If any two or more bulbs have the same brightness, states which one. Justify your answer. So before I start solving this question, I'm gonna write, the brightness is usually the power. So I need to write what the power is equal to. Power is equal to I times V, or I squared R. If I replaced V with Ohm's law, V is equal to IR. Or power is equal to V squared over R. So either of these equations is valuable to use for solving for power, and power means the brightness. So when I look at my equation, I see that the current is going to flow here. So the largest current is going to be right here. Then this largest current is going to split into two. One is going to go this way, and another is going to go this way. But then again, you're going to have this whole current, the one that was you had at the beginning. So all this current that you had at the beginning will unite and come back to the battery through resistor A. So I see the power on A is going to be I through A squared times the resistance. But let's do it this way. We're going to call the currents I, B, C, I, D, and this current we're gonna call IA. What I see is IA is the largest. Then because BC branch, this branch has more resistance than that branch where D is, so the current on D is going to be bigger than the current on BC because BC has more resistance. So I know that the power on D, the power on D is going to be bigger number than, so ID times R is going to be the next one. And then the last one is going to be the power through BC because they have smaller current through them. So when they tell me to line them up in order of brightness from the brightest to the least bright, I'm gonna say my A is the brightest, and then it's gonna be D, and then B is the same bright as C because they carry the same current, BC, through them. So for the next question, for C, they say bulb D is then removed from its socket. Describe the change in the brightness, if any, of bulb A when the bulb D is removed from the socket. Justify your answer. Describe the change in the brightness, if any, of bulb B when the D is removed from the socket, and justify your answer. So I redrew for you two circuits. So they removed D. So this was our D. So they removed D from the circuit, and they ask you what is going to happen to B and A. And before I start solving this and just telling you the answer, I want to show you an example. So let's look at this. I have a circuit where I have something like this. Let me see. And I'm just going to combine B and C together so it will be easier. So I have 6 ohm resistor, and I have 3 ohm resistor. And then I have 1 ohm resistor, and I have 12 volt battery. So I see these two resistors connected in parallel. So if they're connected in parallel, I can find their resistance. I have 1 over plus 1 over. The common denominator is 6. So on the top, I'm going to have a 3. So if I times this by 2 and this by 2, so it's 1 over 1 over, the result flip over. So I can replace, instead of those two resistors, just place one equivalent resistor, which is 2 ohm, because my result has to be flipped over. And then I have a battery and a resistor. So this one is 1 ohm, and this is 12 volts. So what I have now is, very interesting fact. So the total resistance right here is 2 ohm. So when you have two resistors in parallel, the total resistance of both is smaller than the smallest. So you had 3 ohm and 6 ohm, but your total resistance was smaller than the 3 ohm. So when you have two resistors in parallel, their total resistance is always going to be smaller than the smallest. So when I look at this circuit, it looks that the current goes from positive to negative. So the current is going to be 4 amps because the voltage is equal to I times R. Your voltage is 12, your total resistance in series right now is 3. 2 and 1 gives me 3. So the current is 4. So the power on 1 ohm resistor, the power is equal to I squared R, which is 4 squared times 1, and gives me 16 watts. Now, if I remove my 6 ohm resistor from this circuit, I don't have this 2 ohm resistor connected between these 2 points anymore. So all of a sudden, my total resistance is 4. That affected my current. My current is not 4, my current is 3 amps because so the current dropped. So you used this much current before you took that resistor away. Now your current drops. So if the current drops, then the power on A is equal to 3 squared times 1 and equals to 9 watts, right? 9 watts. So when I remove resistor D, my current is going to drop because before you had in this circuit, the one that I have on the right, my B was R and my C was R. So between these 2 points, I have 2R because they are in series, and my D was 1R. So my total resistance, if I replaced all of them with one resistor, would be less than 1, because my total resistance is smaller than the smallest, and the smallest I have 1R, the D resistor. So if I remove the D resistor, my resistance between the 2 points increases. If the resistance is increasing, the current is dropping, and if the current is dropping, then the power on A is going to drop. So describe the change of the brightness, if any, of the bulb A when the bulb D is removed. So the brightness of A is going to go down because the current through A will be dropped. And I use the power equals to I squared times R. That would be my explanation. Now, describe the change in the brightness, if any, of the bulb B when the bulb is removed from the socket. So I'm going to go back and put my 6 ohm resistor so it will be easier. So I'm going to clean a little bit and then come back in a second. So I place my 6 ohm resistor back. Let's look at this part of the circuit. Between these 2 points in blue, I have the voltage drop equals to I times R, which is 8 volt. So between this point and this point, I have, let me call A and B. So the voltage between A and B is equal to 8 volts. Then the current through your 3 ohm resistor, which is where our B is located, is 8 over 3 amps. I don't need the bottom circuit anymore, so I'm going to erase the bottom circuit. I don't need it anymore. I just needed to see that that was 8 volt. And now when I know this part, I'm going to redraw the circuit without 6 ohm resistor. So I have 12. I still have 3. And I have 1. And 12 volts. So this is 1 ohm resistor, this is 3 ohm resistor. And we said, so in this case, my current was equal to 4 amps right here, and 4 amps right there. And the current here is 8 over 3. And I don't care about what goes through 6 because they don't ask and it doesn't matter right now. So when I look at the bottom question, my current is now 3 amps because the total resistance is 4. 12 divided by 4 is going to give me 3 amps. So back going to the power is equal to I squared R. So through 3 ohm resistor, I have the power is 9 times 3 27 watts after I remove the 6 ohm resistor. But before, the power was 8/3, which is smaller than 3 squared. Before you had 3 squared, or after you removed the 6 ohm resistor. So you have 3 squared, and here you have 8/3 squared, which is less than 3, times the squared, times 3. So the power before is lower than the power after. So the brightness of bulb B is gonna go up. So the answer for this part, B, is gonna be brighter because the current through B will increase after you remove D.